So, good evening, everyone, and this is optics lecture number 15. We are in refraction at plane surfaces, and in the last class, we were dealing with what happens when you have a glass slab and you are watching the object from the other side of the glass slab. I hope you all remember this. Yes or no? The object was on the other side. We are watching it from the other side of the slab. We have seen that the glass slab would be shifted, and the amount it shifts is given by T into 1 minus 1 by mu, where mu is the refractive index of glass. I also told you that if this glass is surrounded by some other medium which is not air, then the formula becomes, instead of mu, you write mu r, where mu r is the refractive index of glass with respect to the medium surrounding it. Then I asked you a question: what happens if I have a number of glass slabs like this? Let us say n number of glass slabs I have, each having refractive index mu1, mu2, mu3, and so on, and thickness T1, T2, T3, and so on. What will be the total shift? If I place an object here on this side and I watch it, my eyes are on the other side, what will be the total shift? Anyone? Niharika, Abhiram, the rest of the students in the class, what will be the total shift in this case if I have n number of glass slabs put one after the other? What will be the total shift? Any idea? The total shift x would be equal to x1 plus x2 plus x3 up till xn, where what is this x1? Where what is this x1? This x1 would be the shift due to first slab, x2 would be the shift due to the second slab, and x3 would be the shift due to the third slab, and so on. You can also you also know the value of x1. What will be the value of x1? Can you tell me? The value of x1 would be t1 into 1 minus 1 by mu1. Do we understand this? Yes or no? Similarly, the value of t2, x2 will be t2 into 1 minus 1 by mu2, and so on. We will just keep on adding the shift due to each and every slab. Shift due to each and every slab we will add, and we will get the final total shift. Do we all understand this? Can I have raised hands from everyone in the class? Just raise your hands, and Chintal Center, is there anyone who can talk? Just tell me whether it's okay or not. Do we understand this? Niharik understands this? Okay, well done. So this is all about the topic which was known as normal shift. This was normal shift. Now, in this class, what we are going to deal is the next thing which I will call as optical path. So write the next use of refraction at plane surfaces, which is known as optical path. Now, what is this optical path? What is this optical path? Now, light has the fastest speed in vacuum, that is c. When light travels in some other medium, the speed is less. Whatever time it takes in crossing that medium, in the same time, how much distance it travels in air or vacuum, that distance is known as optical path. So optical path is the distance traveled by light in vacuum in the same time in the same time in which it travels in a medium. That is how this optical path is defined. Now you don't have to understand or remember that definition of this optical path. What you have to understand or remember is, if you have a glass slab, and let me make a glass slab here. If I have a glass slab, let us say this, and this glass slab is of width or length x, and this glass slab has a refractive index mu. So when light crosses through this glass slab, it will travel a distance x. It will travel a distance x inside this medium whose refractive index is mu. So we call the optical path. Now optical path would be how much distance it will travel in air in the same time. The optical path is mu multiplied by x. This is what you got to remember. If light travels a distance x in a medium of refractive index mu, then the optical path is mu x. Then what is this x known as? This x, my dear friend, is known as the geometrical path. This x is known as the geometrical path. This geometrical path is the actual distance traveled by light in that medium, but it is equal to mu x, which is known as the optical path. Do we understand this? Yes or no? Geometrical path is the actual distance light travels in some other medium. Mu x is the equivalent distance it would have traveled if it would have traveled in air instead of the medium. This mu times x is known as the optical path. Do we understand this? Can I have raised hands from everyone in the class that we understand this? Optical path and geometrical path, and I will show you a snapshot, a tabular form here, which explains the same thing in a tabular form. So here what I've explained is similar. You can see it travels a distance x in a refractive index, in a medium of refractive index mu. The optical path is mu times x. This is the only thing that you need to remember. Optical path is mu x. The geometrical path is x. Now, if I have two mediums, one having thickness x1 of refractive index mu1, the other one having thickness x2 with refractive index mu2, and light travels through this combined surface, then the optical path will be equal to this one, mu1 x1 plus mu2 x2. You just have to remember this optical path concept. It is not going to be used in this chapter of ray optics, but we'll be using it in the next chapter, which is wave optics. So it might not be required here. It will be required in the next chapter, but we must be prepared for the next chapter as well if we are preparing seriously for an exam. Do we understand this? Has everyone written this? Yes or no? No, yes. Once you're written, once you're done, please raise your hand so that I can move ahead in life. The only thing you have to understand and remember is x is the actual path traveled in the medium. Mu x is the optical path, equivalent path with light would have traveled in vacuum if it was not traveling in the medium. And if you have more than one or more than two or more than three such slabs, the total optical path will be x1 plus x2 plus x3, same thing that we did in a large number of slabs put after one another. This concept is the concept of optical and the geometrical path. Can I move ahead in life? To the next topic, next heading. Okay, Niharika has done. What about Abhiram and the class? Okay, class, have you noted it down, beta?
So 1 minute, sir.
Okay. I'll wait. Once you are done, please let me know.
Completed, sir. Sir,
Well done. Then we shall move ahead in life. And the next heading that we are going to write is known as heading number 3, real depth and apparent depth. Real and apparent depth. Now, it's a very common phenomena that we see. Suppose we have a coin that has fallen inside water, and if you are looking at this coin from air outside water, this coin will appear to be raised up. It will appear closer than it actually is. Yes or no? Have you seen this? No. It's nothing about seeing it. If you are not seeing it, you can just put a coin in a bucket and see it right now. No, not now. I mean, once you are done with the class, you can see it. The coin will appear raised up. The coin is in water and you are watching it from air. The reverse would happen. The reverse would happen if the coin is in air and you are watching it from water. If it is in air, which is a rarer medium, and you are watching it from water, which is a denser medium, the coin will appear further away. Yes or no? No, yes. Do we understand this? The actual distance, the actual depth of the coin is known as the real depth, and the depth that we see is known as the apparent depth. Do we know this? Yes or no? No, yes. We have an idea about this. Real depth and apparent depth. Now, can anyone tell me in which case, from where to where will the object appear closer, and from where to where does the object appear farther? From where to where the object appears closer, and from where to where the object, and this is a very simple diagram. If you have the object in the denser medium, say water, instead of writing it as a denser medium, you can write it as water. This is the object here, O. Do you see? The object is here. The red point is the object. It is in water, which is a denser medium. This is D, or I can call it dr. Dr is the real depth. It is the actual distance of the coin from the surface of the water. This is surface of water. Now, because light, when it goes from denser medium to the green medium, the rarer medium, it will bend away from the normal. The light will appear to come from this point. If I call the original point as O, the light will appear to come from this green point O dash. So it will appear nearer. I call this depth as dA or D apparent. So basically what I am saying here is dr is the real depth and your dA is your apparent depth. Now this happens when the object is in the denser medium and you are watching it from the rarer medium. What you have to understand here is the relation between dA, the green commodity, and dr, the yellow commodity. Here you must also remember that the refractive index of the first medium is mu1. Why I'm calling it the first medium? This first medium is the medium where this object is placed. That is the first medium. The first medium is always the incident medium where the lights are coming from. The second medium is obviously the medium where light are getting refracted to. Mu1 is the first medium where the object is. Mu2 is the second medium where the observer or the light is going to. Do we understand this? Yes or no? So you just have to remember four terms here. dr, which is the real depth, the actual distance. dA, which is the apparent depth, which is the depth that you see. Mu1, the refractive index of the first medium where the object is. And mu2, the refractive index of the second medium where the ray is getting refracted. And then you have to remember the relation between these four quantities, and the relation is very simple. dA by dr. You'll have to remember this. Remember it correctly because this is important. If you make a mistake in remembering them, well, that would not do it. Instead of writing it this way, let me write it like this way. D apparent is equal to D real. What will be the relation? Anyone has any idea? Let me ask you first. D apparent is the depth that I see. D real is the, I don't think you will be knowing this, so I will just write it. D apparent will be equal to dr into mu2 by mu1. This is what you got to remember from this entire thing. You can also remember it in this way, which I feel comfortable. This is first way of remembering it. The way I remember it is this way. dA by mu2 is equal to dr by mu1. Now, why I think that this way of remembering it is important and easier is when we will go further ahead into refraction by convex surfaces or concave surfaces, then you will understand why it is easier to remember it in the pink way that I have highlighted. Now remember how I remember it. dr is the real depth. dr is the real depth, and real depth, the object is in first medium. So real depth divided by its mu will be equal to apparent depth. Apparent depth is the refracted depth. Apparent depth divided by mu2. Apparent is always after refraction. So after refraction, you take mu2. Before refraction is real depth. So dr by mu1. This is how I remember it. I will leave it to you how you want to remember it. You have to remember two relations. This is number one, the pink one. You can either remember the pink one or you can remember the yellow one. Doesn't matter, both of them are same. So any one of these you will have to remember. Then you will have to remember something known as the shift. How much the object or object appears to be shifted. Now look at this. The object is actually here, but it looks here. So this distance is known as your shift x. This distance is known as your shift x. And this shift x that we are doing now, the formula for this shift x is going to come in the same form that we had for the glass slab. So this formula is also going to come in the same form as this one, this formula that we had written. And therefore it is easier to remember the shift formula for this one and the shift formula for the real and apparent depth. Do we understand this? How do I get the value of this shift x? This x is very simple to get. It is real depth minus apparent depth. So you subtract the apparent depth from the real depth and you get your answers. I will not go into the calculation part because that is not required. I will just tell you what is the shift dr into 1 minus 1 by mu r. This mu r is the relative refractive index of the first medium with respect to the second medium. Once this formula take this yellow form, now you can compare it with the formula for shift that we had written and you will understand, bacha, that both the formulas are of similar nature. Now remember, we have derived this formula for object going from denser to rarer. What will happen if the object goes from rarer to denser? Does the formula change? No, the formula does not change. You can find out real depth and apparent depth using formula number yellow, upar wala, or you can find out from the pink one. It does not depend on whether the object is in denser medium or rarer medium. Do we understand this? Yes or no? And we will do problems to understand this. Do we understand this? Yes or no? You just have to remember the name of the terms that we have used: real depth, apparent depth, mu1, mu2, and remember the relation. I'll give you 2 minutes to note this down. Have you noted it down, beta?
Yes, sir.
Everyone in the offline class?
Yes, sir.
Okay. Now we will try to apply this in a question and see the question may be from denser to rarer, it can be from rarer to denser, doesn't make any difference. Once we have understood the formula, once we have understood the terms which have come in the formula, Doesn't matter from where to where the ray is going. And here is the first question on this real and apparent depth. An object lies 100 centimeters inside water. So what is this 100 centimeter? Definitely this is the real depth. An object lies 100 centimeters inside water. It is viewed from air. Find the apparent depth of the object. Apparent depth is the depth that you see, we see, I see. Will it look closer or will it look farther? This is what you can tell me straight away. Will it be looking less than 100 centimeter closer to us, or will it be looking farther away? Yes. Will it look farther or will it look nearer, beta? No one has an answer? Okay, then tell me the final answer. I'll give you 2 minutes to solve this. Anyone with any answer? Shall I do it? What is this 100 centimeters? Okay, one thing is not given. The refractive index of water is not given here. So refractive index of water is 4/3. One thing was missing. Okay, I did not see it.
75 centimeters.
75 centimeters is the answer. That is correct. Yes, that is correct. Well done. The refractive index of water was missing. Remember, I always forget it. Whenever water is there, refractive index is 4/3. And whenever there is a question of glass, the refractive index is 3/2 or 1.5. These are the pet things that will come here. So they may be given, they may not be given in any question. You just take it. 4/3. So how do you do it, bacha? Tell me. We just apply the formula. D apparent is equal to D real into mu2, the second medium, divided by mu1, the first medium. As soon as we remember this formula correctly, then we don't have to worry about anything else. We just have to put the values here. D apparent is what we need to find out. D real, what is the value of D real? It is given already. The real depth is 100 centimeters, 100 multiplied by the object is inside water, so that is mu1, and it is viewed from air, so that is mu2. So I now put the value of mu2. Mu2 of air is 1 divided by mu1 is water. It is inside water, so it is 1 divided by 4/3. 3 will go in the numerator, 4 will remain in the denominator. 100 divided by 4 is 25. 25 multiplied by 3 is 75. And that is the answer that we were expecting. It should look closer than it actually is. And it is definitely looking closer than it actually is. That is the answer. The answer is definitely 75 meters. 75 centimeters, sorry. Do you all understand this? Yes or no? No, yes. Well done. I hope everyone was able to do this. Remember, this was the case when the object was in the denser medium and we were watching it from the rarer medium. Now, let us see if the same thing works other way around. And now, this is the next question coming on your screens right away. Things have changed. The object lies 90 centimeter in air above the water surface. Question number 2. I think it is from your module. It is viewed from water, so that is our mu2. Find the apparent height of the object. Again, one thing is missing. Mu of water is not given. Mu of water should be taken as 4/3. And I wait patiently for your answers. One two 2.5. Okay. I got one answer. 122.5. 112 is greater than 000. What does that mean? Okay. Some printing mistake, some typing mistake. How are we supposed to do this, my dear friends? Yes, can anyone help me out? So again, we have to do the same thing, bacha. D apparent is D real into mu2 divided by mu1. And if I put the values correctly, I should end up with the correct answer. Yes, bacha, you were saying something. Okay, D apparent is what I have to find out. D real is the real 90 multiplied by mu2, the medium from where I am watching it. The medium from where I am watching it. The medium from where I am watching it is water. And refractive index of water is 4/3 divided by mu1. The refractive index where this
67.5.
object is here, 1. So it is 90 multiplied by 4 divided by 3. And the answer is, my dear friends, how much? 90 multiplied by 4/3.
67 point.
Yes.
67.5.
That means it will appear closer. You'll get 120, my dear friends. Yes or no? 120 centimeters, sorry. I hope you can multiply this. 90 multiplied by 4/3, or shall I help you out, Dad? Yes or no? No, yes? 90 multiplied by 4/3. Do we understand this?
Got it, sir.
See, a simple mistake, sir. And the entire answer becomes wrong, sir. Do we understand this, sir? Yes, sir, or no, sir?
Yes, sir.
Will you be more careful, sir, next time, sir?
Yes, sir.
Then I always keep on telling students that students are like cash cards, cash vouchers. They can always redeem themselves. By redeem, I mean they can do things better in the next attempt. That's what I call redeeming yourself. And you have a chance for redemption. If you can do this question, that means you have understood the entire concept and whatever questions we have done before, even if you could not do it in the first attempt, that is immaterial. This is the question that comes Wow. There's a bird, eagle, fish. And you might see how eagle catches its prey, and you will now understand how difficult it is for the eagle to catch its prey. Because eagle, the bird, is in air, fish is in water. Eagle does not understand refraction, or maybe he does. So what he actually sees, the fish, where actually he sees the fish is actually not there. Fish, where he actually sees bird, the eagle is not there. That is what you have to find out. You have to help these people out. They don't know refraction, but still the eagle catches the fish. See the figure. Find the apparent height of bird. Now, when I say apparent height of bird, it means the height which the fish would see. The actual height, as you can see, is 36 centimeters. Do we get this? Yes or no? No or yes? The real height is 36 centimeters from the surface of water. You have to find the apparent height of the bird. The apparent depth of the bird, of the fish. The fish is also 36 centimeters below water. But what will it look like from air? At what distance will the bird appear to the fish? To the fish, how high will the bird appear? Secondly, at what distance will the fish appear to the bird? The bird, the eagle, how far will the fish actually appear to him? The actual distance is 36 plus 36, 72. That's the actual distance. But what will bird feel and what will be the fish feeling? That is what you got to tell me. And I think we are more intelligent than the bird and the fish. We should be able to do this. Yes or no? No, yes. Huh? No response? Not a good sign? Yes, I got one response. 48 centimeters. Well done. That is the first answer. 48 centimeters is the apparent height of the bird. Fish is watching the bird from the surface of water. It will not look 36 centimeters above. It will look 48 centimeters above. Well done, my dear friend. But the question does not end there, my dear friend. What is the apparent depth of the fish? And then you need to find out at what distance will the bird appear to the fish. At what distance will the fish appear to the bird? Let's see who gets this one. Time is running out. Slowly but steadily. Aviram has given me the second answer. When Ganna class is 28 centimeters, not correct. 27 is the correct one. So we have the correct answers for the first and the second question, but I'm still waiting for the third and the fourth one. Let's hope that I get all the four correct answers. I would be the happiest man alive on this universe right now if that happens. Waiting, 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 waiting. 84 is the third one, sir. Right, sir? That is correct, sir. What about the fourth one? At what distance will the fish appear to the bird? Yes. You have 1 more minute to show your talents. Else I will start my clock. Clock, clock, clock. One more minute. And we are done. Dang, dang, dang. 65 is not correct, beta. Made a mistake. Chalo, then it's my duty to do it now. Let me find the apparent height. H apparent will be H real mu2 divided by mu1. Be careful about mu2 and mu1. If I make a mistake there, then I am not going to get the answer anyway. So actual height is 36 multiplied by mu2 is where I am watching it. From where am I watching it? I am watching it from water. So 4 by 3 divided by where it is. Actually, it is in air. So 1. So 36 into 4 by 3. And the answer in this case would be 48 centimeters. If you got this answer, congratulations. You have done the first part correct. 48 centimeters is the first answer. Let us move ahead in life. Life has to move on. Let us do the part second. Again, I apply the same formula. H apparent is H real into mu2 divided by mu1. Second part, the green one. Now, how does fish appear? How does fish appear to the bird? So the actual depth is 36. The bird is in air, 1. The fish is in water, 4 by 3. So now the answer becomes 27 centimeters. Do we all get this? Yes or no? No, yes. Okay, if we are done with this, then the rest is pretty simple. The rest is pretty simple because now we have to find out at what distance the bird appeared to the fish. Bird appears to fish. Fish is in water. She's at 36 centimeters depth. So 36 is the depth which fish is actually in, plus whatever she feels is the height of the bird, and that is 48. So 36 plus 48, 84 centimeters or meters or whatever it was. That would be the distance that the bird would appear to the fish. Similarly, the distance which the fish appears to the bird is 36 centimeters in air, and then he feels that the fish is 27 centimeters below water, 63 centimeters. If you have done this question correctly, congratulations. You have understood the concept of real and apparent depth. How many of you could do this? I can see all of you. I hope that you all have done this. Yes or no? No, yes. Can I have raise hands from everyone that we could have done this? We have done this, everyone. Well done. Then congratulations all of you, because we have successfully navigated through a tricky phase in our journey here. This was a tricky phase because many of the students, they get confused in this refraction. So I hope that we have gone through this. 2 or 3 more points are still left here. We will be dealing with those points in the next class, and then we'll move on to prism, so that once we are done with plane surfaces, then we will venture into the curved ones, and we'll try to wind them up as soon as possible. Please remember, my dear friends, I've sent you the sheet. Please solve problems from the sheet. The more the number of problems you solve, the better you are going to fare in the exam. So I'll see you on the next side. Happy Dashera in advance to all of you. I guess we'll be meeting after your vacations. So see you there. Have a nice day. Have nice vacations, but don't get too involved.
Sir, happy Dasra, sir.
Yes, please study as well, beta, because Dashera is there, but we need to study as well. So enjoy the festival, but also study. Take care. Have a nice day. God bless you all, bacha.